A client met his banker to discuss opening a restaurant in a busy airport. In us, he found a partner that understood the importance of reaching for the sky. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Mac.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again, and thank you for joining us on the podcast we call Space Nuts. Several hundred, maybe thousand to a pack these days, so I think we're going to have to just make smaller packs because, carrying around a pack of 10,000 space nuts is just, it's not feasible. We'll work on that. But it's great to be with you once again. After trial and tribulation and travel, we finally catch up with one Professor Fred Watson. Hello, Fred.
Hey, Andrew. How are you doing?
I'm really well. Now, you're sitting near a very small rock that was discovered in 1873 in Central Australia and was dubbed by a surveyor named William Goss as Ayers Rock. But in 1993, the dual naming policy of the then government had its name changed to the Aboriginal word of Uluru, one of the great wonders of this country.
Which apparently doesn't have any meaning. Apparently Uluru is just a name rather than something that has a meaning to it. And it is, yes, it's one of the world's biggest, I don't think it is the world's biggest, but it's one of the world's biggest monolithic rocks, a monolith.
And it just sticks out of the middle of nowhere.
Yes.
I've never actually been there, but it's one of my goals, one of the bucket list goals to go and have a look at it. Although people used to be able to climb it, but I think that's just about to come to an end if it hasn't already.
It is. It comes to an end very soon.
Are you and Marnie going to have a crack?
Certainly not, no. But Marnie's done it before, a long time ago, when it wasn't quite such a controversial issue to climb as it is now. But she said it was very hard work.
Yeah, so my parents have done it, and they said it was a really tough climb.
Tough climb.
Yeah, and there have been fatalities in years
Indeed.
gone by. So it's not something for the faint-hearted, really.
That's right.
I'll be happy just to look at it.
Yes, so will I.
Now, today we are talking about the Andromeda Galaxy. It appears that our neighbour is very hungry and it's inviting itself over for lunch. We're also going to look at an asteroid breakup that may well have triggered an ice age. And we've got some really good questions this week. A follow-up to last week's Planet 9 theory and how we might be able to identify Planet 9, if indeed it's a planet. Maybe it's not. We got a question which dates back a little while, but we're still playing catch-up from Kevin about Jupiter's clouds, and a question of Mars becoming habitable once the sun starts to expand and Earth is no longer a place to be. So we'll tackle all that today on episode 174 of the Space Nuts podcast. Now, Fred, what's Andromeda up to, and why is it inviting itself over for a feed?
It's a really good question as to whether it's our galaxy inviting Andromeda or Andromeda inviting our galaxy, because they're probably roughly the same size. It's actually not so easy to tell. Remember, Andromeda is a galaxy rather similar in appearance to ours. It's a large, flattened spiral, very much the same shape as our Milky Way galaxy, and it's about 2.5 million light years away. So it's relatively close in galactic terms. And in fact, Andromeda and our own galaxy are the two biggest members of something we call rather parochially the local group of galaxies. So where the big cheese is in those galaxies. Now, we know that, and we've known for some time that these two galaxies are on a collision course, with about 4.5 billion years being the crunch time when they actually meet. what happens when that collision takes place is a little bit counterintuitive. It's because both galaxies have got so much empty space in them that not really a lot happens. In terms of direct collisions between stars, there will probably be very few, if any, of those. But what will happen is the gravitational interference of one galaxy with another. This probably will work for both galaxies, because both Andromeda and ourselves are pretty rich in hydrogen, the raw material of stars. The collision of these two hydrogen-rich galaxies will almost certainly set up shock waves as they come together, which will probably promote a burst of star formation. So there should be a lot of celestial fireworks in 4.5 billion years' time. Quite a long time to wait, but your diary probably goes that far. Mine certainly does.
Take a few more vitamins, we'll be right.
That's right. Excuse me. So that's part of the story that's come from some work done by colleagues of mine here in Australia. This is a study that is led by Dougal. God, I'm getting his first name wrong.
My wife does that to me all the time, Fred.
It is Dougal. It's Dougal Mackay or Mackay, depending on whether you anglicise it Scottify it or Australise it. He's at the ANU. Dougal's at the ANU, but he's working with Geraint Lewis, who's a friend and colleague from the University of Sydney. Geraint, of course, a good Welsh name, so you've got a good Scots name and a good Welsh name there together. They've done this work, which is published in that prestigious journal Nature, and found evidence of the Andromeda galaxy growing by consuming other smaller galaxies as long ago as 10 billion years ago. We know that our own galaxy has gobbled up smaller galaxies. In fact, it's in the process of doing that now with the two Magellanic Clouds, which are kind of both on a death spiral within the halo of our own galaxy, being stripped of their stars by gravitational interactions, and those stars will find themselves part of the halo, the spherical halo of stars that surrounds the flattened disk of the galaxy. So what Geraint and Dougal have done is looked at globular clusters in the Andromeda galaxy. Now, globular clusters are sort of more or less spherical clusters of stars. They were first identified by William Herschel back in the late 1700s. He gave names to a lot of things, and globular clusters is one of the classes of objects that he named. We now believe that they are the sort of stripped down nuclei of dwarf galaxies. In other words, they once had their own large retinue of stars, not 100 billion or so, like the two big galaxies, or several hundred billion, but more like a few billion perhaps, to make up a dwarf galaxy. So excuse me, I'm losing my voice, as you do when you come to Uluru. The studies that Geraint and Dougal have done have identified two globular clusters which they believe are probably the stripped down remains of dwarf galaxies that were eaten, as I said, about 10 billion years ago by the Andromeda galaxy. But what's really interesting is that they are in the globular clusters are in orbits around the Andromeda galaxy, but the two orbits are at right angles to each other, and that suggests that the two dwarf galaxies that were eaten up by Andromeda came from two different directions at right angles to one another, and that kind of strikes a chord because we believe that the underlying framework of the way galaxies are distributed in space is something we call the cosmic web. And it's basically a scaffolding of dark matter, if I can put it that way, which which the hydrogen congregates to because of the gravity of the dark matter. And in doing that, then you get galaxies formed under their mutual self-gravitation. So the suggestion is that these two globular clusters have come from two different bits of the cosmic web, if I can put it that way. The cosmic web's like this giant honeycomb almost of dark matter. And if you imagine galaxies being strung out along the cosmic web, and then there's Andromeda sitting perhaps at a place where two of these web-like structures come together, that is why you've got this, these two globular clusters in orbits at right angles to each other. And so what they're suggesting is that each of them is symptomatic of a feeding frenzy by the Andromeda galaxy, but two separate ones, which might be separated by billions of years. There's still work to be done on this, but it's a really interesting idea.
And the question remains, what happens in 4.5 billion years' time when we intersect with Andromeda? You've already said we're already consuming some of these dwarf galaxies, so Andromeda's doing the same thing. But when you put two heavyweights together, what is the effect?
Well, they beat one another up basically because they're pretty well matched, and so there are simulations on the web showing what will happen to these two giant spirals when they come together.
Are they likely to merge permanently or pass through each other?
Yeah, they will merge permanently, but it will be a long and painful process because what will happen at first is their stars will pass through one another, so effectively one galaxy moves through the other, but it doesn't leave either of them unscathed because it pulls the spiral arms out into almost straight lines. It kind of unwinds the spiral arms of the galaxies in a way that we can see elsewhere in the universe where there are other pairs of galaxies that have collided. There's a very well-known pair of galaxies called the antennae because they look like the antennae of an ant. And they've got, the strings of stars strung out along the antennas. So that will be what our galaxy, the merged pair, look like after, maybe 1 billion years or 500 million years after the collision. But eventually they'll all come back together and you'll get a really messy single galaxy made out of the two. And probably, and here's another interesting aspect of this, the black holes, the supermassive black holes at the center of our two galaxies will combine. That itself will.
So that's unavoidable. That's just going to happen.
I think that will happen, yeah, especially if there's something like a direct hit. And that's the way it seems to be at the moment, looking at the future.
Wow, fascinating. We'll just have to be patient while we wait for this to happen, so we can see it all. It'll change the sky even before the conglomeration happens. I imagine that anyone or anything that's around at that time will see the sky completely differently to the way we're seeing it now. I would imagine.
Yeah. That's right. When in the lead up to the collision, there'll be a gigantic spiral galaxy in the sky, as well as the Milky Way itself, which we'll be able to see. So it will be very dramatic.
And what I know somebody's wondering, but what of Earth if it's still around then?
Yeah. So there has been a suggestion that Earth will pass through all this unscathed. Of course, by then Earth's getting pretty warm because the sun's turning into a red giant by then. Yeah. And I think that's we're going to talk about in one of the questions. But it would be bad luck for the sun and its family of planets to be flung out of this merged galaxy. But it's not impossible because there will be stars that will be flung out into space, I'm sure.
It sounds like a corporate takeover.
Exactly so.
On a universal scale.
Yeah.
All right. Well, we'll just have to be patient and watch that one very, very slowly. You're listening to Space Nuts with Andrew Dunkley and Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
0G, and I feel fine.
Space Nuts.
Now, Fred, as we have been doing each week, just a big thank you to our patrons who put a couple of dollars in each month to support the podcast. There are 56 of them now. And we have a question from one of our patrons, which we'll be answering shortly, or endeavouring to do so. So thank you to everybody who has decided to join us and just put a few dollars each month in to keep the podcast going. We really do appreciate it. It's a wonderful gesture. It's certainly not something you have to do, but the fact that you want to do it, it's very humbling, and we greatly appreciate it. So thank you very much. And more to come with those who join patreon.com/spacenuts, because we're working on value adding, I guess is the best way to put that. So thank you again. And of course, if you do want to do that, go to patreon.com/spacenuts and choose whatever level you want to join at. It's not expensive at all. Now, Fred, we are going to look at this particular asteroid smash-up, as they're describing it, which dates back 460 plus million years. And now it's thought that this particular event may have caused an ice age on Earth. That sounds rather unusual or interesting, or both.
Yeah, it's. I mean, when we talk about asteroids, we particularly prehistoric ones like this, we think of the dinosaur the dinosaur asteroid collision, which happened 66 million years ago, and basically an asteroid hit the surface of the Earth, something maybe about 15 kilometers in diameter, and the debris from that explosion, from that impact, very quickly blanketed the Earth with dust and debris, and caused a sudden drop in temperature. And this is a drop that, might have only taken months or even days or weeks rather than years or decades. It was very quick. And it's that caused the demise of the dinosaurs, because they basically had nowhere to go. The thing happened so quickly that their environment was effectively totally destroyed.
Yeah, that's why goldfish die. People pour cold water into a fish tank. It's the same thing.
There you go. A little bit of folklore from Andrew Dunkley. Don't pour cold water into your fish tank.
No, they need to acclimatise.
It's got the same effect as the asteroid had on the dinosaurs. But this is a different sort of collision. There is evidence, and I'll come to that in a minute, but there is evidence that about 466 million years ago, 400 million years longer back in the past than the dinosaur demise, there was not a collision of an asteroid with the Earth, but a collision of an asteroid with another one, probably a smaller one.
Hence the smash-up.
the big one is thought to have been 150 kilometers in diameter, which is actually 10 times the diameter of the one that killed off the dinosaurs. So you've got this object, 150 kilometers in diameter. Something runs into it. Probably it may even have been one as big, but whatever it was, there was an impacting object, which effectively demolishes the big asteroid, reduces it to rubble. So that basically has a number of effects, but the bottom line is it fills up the inner solar system with dust. So there's some interesting numbers here. We know that something like 1% of the dust in the Earth's atmosphere today is from a meteorite. It's meteoritic.
Yeah.
But the few million years after that breakup of that asteroid, 466 million years ago, that put 10,000 times more dust into the Earth's atmosphere. So, it just means that the meteoritic dust increases by a factor of 10,000. And so what you've got is a blanket of dust in the Earth's atmosphere that reduces the temperature. What you also have is dust in the inner solar system, which reduces the amount of sunlight that's coming from the sun to the planet. So you've got a double whammy here. The sunlight's reduced, but also the atmosphere, the opacity of the atmosphere. It's the light that it absorbs or shadows. That also reduces the radiation falling on the surface. So for a long period, the Earth's temperature is lower. Now, the evidence for this comes from micrometeorites in the geological layer that coincides with this 466 million year old impact. The geological layer over a period of, I think, something like 2 million years is characterized by these micrometeorites basically in the strata. I think they are approximately the size of a coin. They're quite small. They're just little bits of debris, but they tell you that there is also dust in the atmosphere. Sorry, as well as the dust in the atmosphere, there's micrometeorites. Somebody's ringing me there, so I'm just sending a message. So I can't talk to you. That's why I'm blank. Yeah.
If you want to get a phone call, start recording a podcast.
A podcast, yeah, exactly. Quite so. And of course, people like me are hopeless at multitasking. I can't talk and think at the same time. So micrometeorites are what tell you that there was a lot of stuff in the Earth's atmosphere, because that's found its way into the geological record. Mm-hmm. But it's a slow process. This is the key thing. And that is the really interesting part of this story, because, yes, exactly as you've said, it basically created an ice age. But that ice age was so gentle and slow in coming that, unlike the phenomenon where the dinosaurs were wiped out, what happened is evolution was ahead of the game. So species evolved because of the fact that the temperature was cooling. They evolved to cope with that. And actually, instead of an extinction, you get what is known in the trade, apparently, as the Great Ordovician Biodiversification Event, or the GOBI, Great Ordovician Biodiversification Event. And that's telling you that there were more species, a huge blossoming in the number of species. One author commenting in this on the Cosmos web page is actually Richard Lovett, who's always got away with words. He talks about their, not a mass extinction, but an evolutionary kick in the pants for life to adapt. And that's what gave you this GOBI, the Great Ordovician.
So in real terms, it was the opposite to the dinosaur asteroid.
Yeah, right.
And it was a slow burner, and life kind of just exploded as a result of the effects of this.
Yeah, that's right. a bit counterintuitive, but people seem to, the commentators on this work who are not connected with it, they seem to like the idea. They think that's a really good explanation for this biodiversification event that until now I think has lacked a mechanism that would have caused it. So really interesting stuff. And as you said, counterintuitive, although there is a big difference between an asteroid hitting the Earth and two asteroids colliding in between Mars and Jupiter in the main asteroid belt.
Now, as you said, some of that dust ended up on Earth and cooled the planet and ice age and blossoming life. Is there still evidence of that collision around us outside the planet?
It's in space.
Yeah.
I don't think there is. I think what would have happened, 466 million years is a long time for the dust to dissipate through the rubble essentially. It was thick for a while, but now it's cleared. It's a bit like
we passed through the remnants of comets. That's, I guess, what I'm getting at.
Yeah, that's right. But you're talking there about decades or hundreds of years. The dust clouds.
This is millions.
This is millions of years. So it's a bit like those dust storms that whiz by your city.
We had one yesterday.
The other day, and there was a dust storm on its way.
There's a city down the road from us called Orange. We're thinking we need to change names. Because
yes,
our city's been orange every other day due to dust storms in recent weeks.
But they do dissipate. That's the thing, as does dust in the air.
Well, I know this is a bit of a sideline, but the interesting part about yesterday's dust storm is we were blanketed for most of the day and the whole sky was orange. And then it cleared and the sky was blue and then it came again. So it was a weird day. It was a truly weird day.
I have photographs a photograph from Siding Spring Observatory taken actually this morning that shows basically the whole district enveloped in dust. It's clearly a big problem up there.
Yeah, we've got the drought, which I got the latest climate data yesterday, and it's very, very bleak. We are looking at less than a 30% chance of median rain for spring, going into a hot summer where we've already seen the fire season start, and there are lots of houses being burnt down north of us, and that is how the fire season works here. It goes north to south, so we're not into the thick of it yet. So it's a very big worry. Our dam is down to 4%, and they're talking about running out of water in the not too distant future, although people are arguing over when that might happen. Some are saying, we've still got 10 years worth, and some are saying, no, there's only 2. So who knows? When the authorities start arguing, you just throw your arms up and walk away. But it's dust is an interesting subject, believe it or not. It sounds boring, but it basically is everywhere, in everything, and has had a huge effect on our lives over millions of years. So here we are. And we continue to get dusted out. I think the government should invest in giant space vacuum cleaners, and then we'll be fine. Solve all our problems. Yeah, but that one's interesting. So the Gobi, I'm not going to even try and say what it was, but 466 million years ago, which caused a slow ice age and a blossoming of life. Very, very good. You're listening to Space Nuts. Andrew Dunkley here, Fred Watson just over there.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, we're going to bump off a few questions, which makes it sound like we're going to make inroads into our question list, but a couple of these came in today. And one of them came in 2001, and we'll be bumping those off. But we've made no inroads into lessening the size of the question list. But we will probably do another episode soon where we just tackle questions. So stand by. If you have sent us questions, chances are it will get on. But if it's been answered in another episode because someone else asked a similar thing, we tend to skip it. So if you haven't heard your question answered, chances are someone else asked it and it was answered in an episode that you may not have heard yet, or you might have missed or something. So start at 1, just work your way through it, catch up to 174, and it should be covered. Fair enough? Probably not. Anyway, let's move on. Now, our first question comes from a someone who actually asked the question through Patreon, Fred, and it reflects on last week's episode when we talked about what Planet 9 could be. We've been looking for a planet, but now they're thinking it may not be a planet. It could be, a black hole or a what was the word we used?
Primordial black
hole. So this comes from David Findlay, and thank you, David, for your question and for being a patron too. He said, Re 173, episode 173, Planet 9. Would such a black hole moving across the star field produce a detectable halo? I recalled the old dark matter concept of machos and IIRC. I'm not sure what he means there. I might be pronouncing it wrong. There were surveys looking for them against background star fields. So what do you think of that?
Yeah, so it's a good question. Exactly as I'm sorry, I don't have this email in front of me, so I've forgotten his name.
David.
Tell me, David. Exactly as David says. Sorry, David. I'm sitting a long way away from Andrew. The idea of machos, massive compact halo objects, which included the possibility of small black holes, and by that I mean Earth or stellar mass black holes, was indeed ruled out during the 1990s by a number of experiments, most notably one at Mount Stromlo Observatory here in Australia, where a very venerable telescope, which was then called a 50-inch, but actually goes back to its origins as a Great Melbourne Telescope in 1869, that was used to look for what's called a gravitational microlensing event. So if you've got lots of black holes, as they flit through deep space, they pass in front of distant stars, and rather than block them out, they actually magnify the light of distant stars. So you should see, a star brighten up and then fade away with a very, very characteristic light curve or shape of the profile of the brightening. And they were not seen in the numbers that were expected if machos was what dark matter was, and that was one of the key things that ruled out that idea for dark matter. The situation with Planet 9 being a microscopic primordial black hole is probably different, but not that much different. In order for this microlensing process to work, you've got to have very great distances between the lensed object and the lensing object, if I can put it that way. In other words, the background star and the foreground black hole or whatever it is, they've got to be a long way apart, as do we as the observer on the Earth. Now, that would not be the case with the Planet 9 hypothesis if it was a primordial black hole of a few Earth masses rather than the planet. So I'm not certain of what the effect would be, given the geometry, given the distance from ourselves to this hypothetical object and the distance from that to the star behind it, which is being lensed. And it may well be that it doesn't work. You don't get the microlensing phenomenon. On the other hand, you might. So I am not sure which of these would be the case. But it's an interesting idea and one not to be dismissed. I think it's a very good comment. Thank you very much, David.
Wonderful. Thanks, David. Appreciate the question, and hopefully it gave you a bit of an indication that you might be on the money. But they keep looking. They'll find this thing eventually, and then we'll go, right.
Yep.
Should have known that's what it was.
Should have guessed.
Yeah, and we probably have. Now, moving on. Here's a question from Kevin Rutherford. Hi, Kevin. Here's a question about Jupiter's clouds. Every image I've ever seen shows complex swirls of many colours. But if Jupiter is a big ball of gas over 4 billion years old, why haven't the swirling currents caused all the different coloured constituents to merge into a single homogeneous cloud, like milk stirred up in a cup of tea, for example? Does the existence of these variegated colours imply that the cloud systems are being constantly replenished with new materials, and if so, where might these come from?
So the way to think of this is very much like the weather on the Earth. We have, characteristic weather patterns. You've only to look at the wind patterns on the Earth to find that we get bands of winds in different directions. The roaring 40s, for example, and the trade winds, things that are all very common parlance.
Well,
and
if you look at satellite footage that's sped up, you can see the same kind of effect as we see on Jupiter with the cloud movements. Right.
So these are cloud movements high in Jupiter's atmosphere. I don't think there's any implication that they're being replenished with new material, although there may be some hint of that. For example, we know the Great Red Spot, which is a cyclone, is very, very deep. It goes very, very deep into the atmosphere, so that might be churning stuff up from lower down. But generally speaking, I think the materials or the chemical constituents, the things that give the clouds of Jupiter their colours and their different structure, are very much akin to what happens on the Earth. It's to do with, the fact that the climate is different from one latitude to the next. What would be surprising would be if they went the other way from the rotation or something like that, vertically rather than horizontally. But the clouds follow very much the same sort of patterns as we see them on Earth. Now, the more remote, the more distant gas giants, starting with Saturn, of course, and then onto Uranus and Neptune, they have got much less distinct clouds in their atmospheres. And I don't think that is put down to it being the phenomenon that Kevin's talking about. When you stir milk into a cup of tea, it just becomes uniform. I think it's more to do with the fact that the clouds on these planets are actually lower down in the atmosphere. The structure is there, but it's actually lower down, and so you don't see it anything like as clearly as you do on the planet Jupiter. And that's because it's cooler. They're all colder planets. They're further out in the solar system. They don't have the same heat input that Jupiter has. That's a fairly wishy-washy and woolly answer, but I think that's the basic point. That weather systems tend to stick where they are and don't just mix up.
There you go. And just like on Earth. So thanks, Kevin. Great question. I'm sure a lot of people have wondered about that one. Okay, now this question came in yesterday, Fred, through the Space Nuts podcast group. So a lot of our Space Nuts listeners who are part of the group have put in their tuppence worth, and fair enough too. But I just saw it, and because it was addressed to us, I thought it's a good question to ask. It's in two parts. From Matt Brown. Hi, Matt. Thanks for your question. G'day, guys. I used to listen to the podcast a heap when operating machines on mines. I've got a new role now and still trying to find time. Well, I'm glad you found time for us to send the question in, Matt. A question for you both. As the sun expands and Earth moves out of the habitable zone, which we talked about earlier, will Mars move into it, and how long before it also gets too hot? That's part one. Do you want to tackle that, or do you want to hear the next bit first?
Let's do it all at once.
Okay, part two. As Mars moves into the habitable zone, we know it doesn't have plates like Earth, hence how Olympus Mons became so large. Will it go through a very violent volcanic era and be almost unlivable as it heats up? Will it crack its giant superplate and melt its own polar regions to become more Earth-like?
Yeah, great questions. So it's really the habitable zone that moves, to move out into the solar system as the sun becomes a red giant. And yes, the Earth will eventually move out of the habitable zone. It will get too hot for us as the sun expands. And Mars will move
at the same time as Andromeda crashing into us.
It's a bit sooner, I think. I think actually this happens to us before the crash. So, it might spoil our view of the Andromeda collision. Mars will receive more solar radiation, so it will become warmer. But in order for plate tectonics to kick in, it's the core of Mars that needs to be hot. And I think you're there talking about temperatures which are much higher than what you would get from radiation. Until it was at such a level that the planet was almost melting because it was so hot. So the core of the iron core of the Earth is somewhere between 6,000 and 7,000 degrees Celsius. And that's kind of hotter than what you would get from being immersed in the outer atmosphere of a red giant star. So it's unlikely that you'd kick in plate tectonics until Mars was almost being swallowed up by the bloated sun. So I don't think it's. I think the scenario of hideous volcanism and things like that is probably nearer the truth than the place just becoming gently more habitable because it's got suddenly develops a carbon cycle because it's got plate tectonics. Mars is an interesting case. We talk about terraforming Mars, but the fact is the planet's too small to hang on to any kind of gases that will be useful to us as humans. They're just too small a world. So, and I think subtle effects like that will probably still be in play if Mars was being heated by the sun in this early red giant phase. So, I don't think Mars is ever going to offer a really good holiday destination for people who are trying to escape the desert landscape of the Earth in this post-apocalypse era. Yes. You might be trying to escape it sooner with your dust storms.
Yeah,
Andrew.
well, we're starting to become Mars-like here. Everything's covered in red dust.
You look a bit like a Martian on the screen there.
I do, yes. I've got red headphones. They were white earlier, and I've got a red car which has always been red, but now it's redder. So it's unfortunately it's just something we can't avoid. But yeah, it's a good question. I suppose the only way to make Mars habitable would be to create microclimates artificially, so domes and things like that, perhaps if technology allows in the future, and create your own mini environments under the domes or something like that. I don't doubt that the day will come where there'll be hotels on Mars. It will be a holiday destination. I think that time will come. I heard today that was it Boeing was going to inject some dollars into space tourism. So everyone's trying to get in on this. It's becoming a big thing.
Indeed, that's right. Yeah.
And thank you very much for your question, Matt. Much appreciated. And thank you to everybody who's listened and contributed. And don't forget the podcast group. If you want to, mix your ideas with fellow space nuts, you can do that at the Facebook Space Nuts Podcast Facebook group. The Space Nuts Podcast group on Facebook. Good grief. We've got to think of a better name. Anyway, we're stuck with it now. So, but I do keep an eye on it and I occasionally do comment there. So they're having a lot of fun, Fred, I must say. Thank you, sir, for your contribution this week. Enjoy Uluru.
Yes, I will. Thank you very much.
And we'll catch up with you real soon.
Yeah, sounds good. Thank you very much, Andrew.
I think we just did what do you call it? The crashing of the asteroids into each other finish. I think we just did.
Yes, that's right. Yeah, the collision ending.
Yes. All right. Thanks, Fred. We'll see you soon.
See you later.
See, that worked. And from me, thanks again. We'll catch you on another edition of Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes and Stitcher or your favourite podcast distributor.
This has been another quality podcast production from Bytes.com.